Hello everyone, I hope you're doing well. This is Cole speaking. Today we're going to be doing Practical 1, Evaluating Utility. Specifically we're going to be doing Part 2, which is Calculating Monetary Gain. This video aims to reduce the content that Mr. van der Bank discussed with us in class in order to summarize it and just to present it a bit more concisely and as accurately as possible. Alright, let's get right into it. Question 1. Calculate the average monetary gain per person resulting from the use of x2 instead of selecting randomly. We can make the following assumptions moving forward. There's a cutoff is still at x15, or x equals 15. The tenure is equivalent to 12 periods. This can be years, month, regardless. And the number of applicants applying for the position is 50. We also see that the cost per assessment is 1,500. So the following steps are required for us in order to calculate the average monetary gain per person. So first we want to calculate the average performance in rand of all applicants in the sample group. We want to calculate the average performance in rand of applicants that met the test cutoff and thus would have been selected, in essence the selected group. And we want to subtract the current average performance in the organization from the average performance of the selected group, thus subtracting A from B. Alright, so before we get started, let's just get some admin stuff out of the way. So in order for us to do this, we know that we're going to be making use of Y1 and X1. A nice little shortcut again, if you want to select all your data, is Control Shift down arrow. We want to copy this, and for neatness purposes we're going to put it into a new spreadsheet. I'm just first going to show you how to format these things accordingly as well. So we open up a new sheet and we paste it as such. So in order for us to be able to use this data a bit more effectively later on, we want to highlight it all again. We want to say format as a table and just keep it as such. Alright, so you see this is how we get to this part here. Don't worry too much about these columns just yet, we'll get to that a little bit later. Alright, so they want the average performance of the sample group. Very straightforward. We say equals average, and then we use the data series for the criterion or the dependent variable, which in this case is performance in rand value. We said that when we do the formula, which is average, we said that we have an average of 48,779.71. Alright, so the second part of the question wants us to calculate the average of applicants that met the test cutoff score. In other words, these are people that are in the selected group, and if we look back at our quadrants over here, we can note that this will include people that scored above 15. So it might be in the case that they did score above 15, but it can be either a false positive, as we remember here, or it can be a true positive, as we remember here. Alright, so basically what we're doing is from the selected group, how are we going to make sure that we can separate these values easily? So as you might see here, all the values are still mixed up. It's very difficult to discern whom of them are above 15 without manually looking at them. So all that we want to do is we want to click here on X1, we want to sort it from largest to smallest, and now we see we can basically see all the 15 values right here. Right, so when we go over to this one, we see that we've got all of the ones up to 15 here. In other words, we want the averages of these. Alright, so in order to do that, we go equals average 82 down to 821 in this case, and this gives us the average of the people that scored above 15. In other words, we see that people who scored above 15 scored an average of 66,912 in the dependent or the criterion variable, which is performance. Alright, and then the third part, also very straightforward, is that we want to subtract the A from B, and we do this by very simply saying we take average performance of the selected group minus the average performance of the sample group. And this gives us 18,132.69, and this is the average monetary gain per person we were to get if we use X2 instead of selecting randomly. This concludes question number 1. Question 2. Create a scatter plot to display the monetary gain. More specifically, they're asking us to create a scatter plot with Y as the dependent variable and X as the independent variable. Alright, so as you can see here, we already have the completed graph. However, I'm going to show you guys again just how to do the scatter plot. So we go into scatter, and now we want to select our data, which is up here. We need to add a legend entries or series. You can make the series name whatever you prefer. I just usually go with the standard plot y1 x2. The series x values includes all of these downwards, and the series y values, my apologies, and the series y values also are dependent to our criterion variable. So when we say okay, we see that now we've got a scatter plot created here. Alright, so now that we have our scatter plot going here, the second part of the question asks us to insert a reference line on the y-axis indicating average performance. Right? So in order to do this, we need to again just make ourselves like this little table, and we see that if we want a reference line running as this one does here, we want to make sure that on the y-axis it starts at 0 down here at x, but it starts up here on the y-axis at 66,912. This amount we got from the average performance of our selected group. In essence, those people who scored above 15. Right, so we say it starts with x0, y 66,912, and it progresses forward to x25, but with y staying constant at 66,912. Alright, so we go to here, we go data, we select data, and then we go add. It can be any series name that you prefer. I will just be using reference line y. We want to select the x values, which are here, and we also want to select the y values, which are these two. Alright, and we say okay, and we say okay. So again, now we double click on these 2 points to bring up this menu here. We want to take it over to the paint bucket to edit it a little bit, and we want to put in a solid line. Also again, noting that we want to make use of a neutral color, so we just want to use black. Alright, this concludes the second part of the question. Let's take a look at the third. Alright, so now we look at the third part of the question. You see they want us to insert a reference line on the x-axis indicating average test performance of the selected group. Alright, so how are we going to be doing this? We want to see here the average test performance of the selected group. So we need to first work this out, or we need to calculate this. In order to work out the average score of the selected group on x2, we take the following formula. Average, and now that we still have our data nicely sorted from largest to smallest, we take the average of B2, which is our top prime candidate 21, all the way down to B21, which is the last person to have scored 15. This gives us an average of 16.9 for the x, and this value we translate right here to the two x1s, because we want this one, the reference line must be on the x. So we see that the line starts at x equals 16.9, y equals 0, which is down here, and then it progresses up, still staying with 16.9 on the x-axis, but reaching 90,000, the top of our data series, on the y-axis. Alright, so then we do the same as we did the previous time. We select our data, we add another reference line. This one you can call reference line x if you'd like, and we take the series values, which are these two for x, and then again for y we take these two. We say okay, and here we see we've got these 2 dots again. My apologies, press OK. Got the 2 dots. We want to make it a solid line. It is already in black. Alright, and as you may remember from our previous practicals, I'm not sure if it was in practical 2, but it's always nice just to format our thing a little bit accordingly. So for example, first we can start by just reducing this a little bit down to 90,000, so as to clear some white space up there. I want to reduce this one back down to 25, and there we go, no white space. And then other than that, you're more than welcome to put in axis titles as well as your chart title, just to make it look nice and neat. Alright, so now we need to visually inspect the difference in performance scaled in Rand. However, in order to do this, we need one last reference line, and this is the reference line where we look at the average performance of all the applicants, right? So in order to do this, we make use of the amount that we got here at question 1, which is the average performance of the sample. We remember our formula that we used, and we take this amount over to here. Alright, so now we want another reference line that runs from here horizontally across. So in order to do that, the first point starts at x equals 0, y equals 48,779. So more or less here, and we want it to run through all the way to 25, but still being 48,779. So in order to do that, we go here, select data, and we can give it any name we like, reference line x2 or x2, whatever you prefer. And then we want to say x values are these, and the y values are these two. Alright, okay. Now we can just edit this thing again, make it a solid line, and let's give this one a slightly different color. Let's make it orange. Alright, so now the last part of the question for us is to visually inspect the difference in performance, scaled in rand. So there's not much one can really do with visually checking out the difference. However, we can see that, for example, the people that we select afterwards, they are on average going to bring us in this amount. However, if we were to select at random using x2, we would only get these people here. However, now we see we climb a little bit. We can actually determine how much that gain is per person when we take this amount here, the 18,132. Because if we take this 50,000 plus that more or less, gets us to just around there. Right. This concludes question 1. Question 3. Calculate the total monetary gain resulting from the use of x2 over 12 periods tenure and a selection ratio, which is this SR of 0.2. So this is the calculation that we need to perform, which is 1C, our answer from here, times tenure times number of people selected. So let's take it back over here. So now we see question 3, the average monetary gain per person, which we got from up here. We see that the tenure is 12. It doesn't specify whether it is months or years, but at the moment they do say 12 periods. So we do have a numerical value of 12. The selection ratio is 0.2. The number of people that applied is 50, but the number of people selected is 50 times 0.2. In other words, for every 50 people that apply, we only take 20% of those people, and as you might remember from class, this results in about 10 people. Right, so here we have the formula, which is the average monetary gain per person from x2 times tenure times the selection ratio times number of people that applied. And thus, if we put in all the values, as we can see here, we simply got them from here, we apply them within the formula, and we should get an amount of approximately 2175922.8. This concludes question number 3. Question 4. Calculate the total net gain. In order to do this, we first need to calculate the cost of assessments, and this is basically saying the cost per assessment times the number of applicants that are assessed. In this instance, we assume that all the applicants are assessed. Thereafter, we need to subtract the total cost of assessments from the total gain that we calculated up here. Alright, so very straightforward. We go over to our Excel page, we see question 4 here. So you see the monetary gain that we got from using x2, which is this amount. You see the cost per assessment, which is 1,500. The number of applicants assessed are 15, and then thus the total net gain is this amount minus these two times with each other. And when we put all of this into our formula, as we can see up here, we get an amount of approximately 2100922.8. Alright, this concludes question number 4. Alright, question 5. Calculate net gain with this utility model. You'll see that we already calculated the net gain here, but this one is using a specific formula developed by these ladies and gentlemen, and we see all the values put up here. So we see that the first one, this little triangle under U, is the increase in average rand valued payoff resulting from the use of selection procedure X instead of selecting randomly. Alright, so this is the one that we want to get to. However, now we need to put in the values into this formula. So let's just quickly make sure what each one represents. So you see the first one is N appoint, which we see is the number of applicants appointed with the procedure. We see T refers to the expected tenure of the selected group. RXY is the correlation of the selection procedure with job performance measure. We see it scaled in rand. SDY refers to the standard deviation of rand value job performance in the applicant group. You see this little dash over the Z, XS, which is the average standard predictor score of the selected group. Just note here, standard predictor, we looked at standard scores. And then we have minus N assess, which is the number of applicants assessed, times the cost per candidate. Alright, so now that we know what all of these values or all of these letters and symbols mean, let's put it into practice. So I'm taking us back over to the Excel spreadsheet, where you might note that I put this in for us as a reference point, and now we're going to figure out where all of these amounts come from. So RXY, our first, this one we get back at practical 1, part 1, which is the correlation between Y1 and X2. We see here 0.801, Alright, then we take that amount over here to the 0.8 section. For the standard deviation of y, I'll come back to this later just to address why there might be a discrepancy between my own and Mr. van der Bank's work. Then to get the ZXS, we need to assume, we know that there was a selection ratio of 0.2. So now we need to go down. I just really want to find this for you guys again. Here we go. So at number 3, they mentioned that there's a selection ratio of 0.2. And this is important as we'll need this to interpret the following table, not this one, but this one. This is the selection ratio conversion table for utility. So we take the selection ratio, which we know to be 0.2, and we match that here with M. And we see that it gives us a 1.4 value. This 1.4 we take back and we put it in here. Alright, then the T, as we know, is tenure, that there are 12 periods. N, a point, is the number of people we're appointing, and as we remember, this was the selection ratio times the total number of people that were applying. So we know that it's 0.2 times 50, which gave us 10. Then we have C, which is the cost per candidate, which they specified earlier as being 1,500, and then finally the number of people assessed was 50. So when we put all of these values into our equation, this is what we get up here. Just times, and then minus those two times. Alright, so let me just quickly address the standard deviation, the difference between Mr. van der Bank and myself. So basically within Excel you get variations of formulas. So as you might see as I'm going between the two, for mine I made use of stdev.p, whilst Mr. van der Bank only made use of the standard deviation, the normal formula. So if you can show the formula that you use, it won't be a problem, and you will mark according to what you used. But basically my rationale for using this one was that we're making use of a population group and not a sample within the population group. But in any case, that's very technical stuff. As long as you've got something that's more or less the same as this, and you make use of the standard deviation formula, it doesn't really matter which one. You should get an amount of approximately 2429283. Alright, so this brings us to the end of Practical 1 Part 2. So just as a quick end off, you might see that there's a difference between these two values, even though they're supposed to be doing the same thing. But as you might recall from Mr. van der Bank's lecture, he did start explaining to us why there might be a difference, and that to him it was a professional curiosity. But for assessment purposes, it is not important for us, especially in the practical end of the exam, to know why the difference exists. The most important thing for us is simply to know how to calculate all of these stuff, how to put it all together, and to get an end amount like this. This brings us to the end of Practical 1, Evaluating Utility, Part 2, Calculating Monetary Gain. So just a short summary of what we did today. We calculated the average monetary gain per person, and we took this information, followed these steps, and as we can see here, we basically worked out the things as they said nicely. Alright, then we went to question 2, which was to create a scatter plot with y as our dependent variable, x as our independent variable, and then taking into consideration the reference line that they requested of us. So here we can see that we've got the reference line on the x-axis, which is 16.9, which is basically to say the mean or the average value of the applicants that were selected on their x scores. And then here, this little orange line we indicated was the average performance of all of our applicants. And then finally up here, we have the average performance of those people who scored 15 and higher. This gave us a nice visual representation of our data and allowed us to interpret it a little bit more. Alright, then going on to question 3, we did this very easy calculation. We basically put it into the formula, so we took the value that we got at 1C, we timed it with tenure, and we timed it with the number of people selected. Again, just to refresh your memory, in order to get to the number of people selected, we have to take the number of people applied times the selection ratio. We put this into the formula and we got an amount of 2,175,000, so on and so forth. Alright, then we go back over here. We did question 4, which was to calculate the total net gain very easily, which was here. So we had the monetary gain from using X2, the cost per assessment, the number of applicants. We put it into our formula and we got this amount here, which was 202,100,000 odd. And then finally we went to question 5, which was all about just being able to find these values and being able to put them into this. So we see here we got RXY from the previous work that we did. We got the standard deviation of Y simply by putting in this formula. We got the ZXS by taking the selection ratio and reading it off this one here. So we saw 0.2 selection ratio. We took it across and got a 1.4 value. Put it in there. T, which is tenure, we knew to be 12. The number of appointed people was 10. How did we get there? We took 0.2 times 50, because there were 50 people that applied with a selection ratio of 0.2. We know that the cost of the assessments were 1,500, and finally we know that the number of people assessed were 50. When we put all of these values into the formula, we got a final amount of 2,429,283.41. This concludes Practical 1, Part 2.